And how many of you learned about object-oriented programming techniques like encapsulation, polymorphism? Good, very large number. The reason that you learn these things is so that your code can achieve reusability, extensibility, scalability in some cases. How many of you learned about secure design principles as a requirement for your degree? Much fewer, like 3. Now, so these principles are important because they will, in a new situation, in a new scenario, they will help you derive what are the right things to do. I've talked about what are the big 4 web vulnerabilities today, but you know what? The big web vulnerabilities might be different tomorrow or the day after. And so it's important to have a top-down understanding of these things. So once you've learned about secure design, the next set of things to learn is, filling it in with experience, right? So for instance, in my book, I illustrate what happens if you don't follow each of these security principles with vulnerabilities in a web server. You need to have a concrete experience with understanding, and so understanding what are all the different technical flaws that we've seen to date. I've talked about cross-site-request-forgery, but there's cross-site scripting, cross-site script inclusion. I've talked about code injection vulnerabilities. There's things like directory traversal, right? If you type in an URL with ////////////////////// password at the end, and the web server happens to be running at root and a couple other things are wrong, well, you might be able to get access to the password file, which might allow you to do a dictionary attack after that. Race conditions. Security vulnerabilities can occur due to race conditions. Time of check versus time of use problems, for instance. And of course, memory corruption. All of these different types of technical flaws can be used to conduct a variety of attacks. You can conduct data theft with cross-site-request-forgery. You can conduct data theft by using a SQL injection attack. You can do denial of service by taking advantage of a race condition vulnerability. So having an understanding of what these different threats are will help you figure out what kind of technical flaws you need to defend against. But I'd say this is probably the core of what every engineer needs to know. So where do you learn this stuff? Well, I'm going to provide a non-comprehensive list. Here at CERIAS, I think you guys are all lucky to have some very good faculty in courses, and I'd encourage you to take advantage of them. I was chatting with Pascal Moiner earlier today, and he has lots of good materials, and I'm sure there's many other faculty who I haven't met with that do. You should surely take advantage of them. For those of you that are in industry and elsewhere, I'll provide pointers to some other courses. Most universities have cryptography as upper division courses, which is good, but an understanding of cryptography is only a small part of what you need to know to build a secure system. Many security vulnerabilities, in fact, most security vulnerabilities happen not due to vulnerabilities in the cryptography itself, but how the cryptography is used, or a mistaken protocol design. While there are cryptography courses at almost every major university, some universities, such as Purdue, such as Stanford, such as UC Berkeley, are offering system security courses that that teach you about software-related vulnerabilities. There's a more comprehensive list at Avi Rubin's website. Feel free to check it out. One of the things that's been frustrating is that very often, as part of undergraduate programs, as part of undergraduate programs, universities don't require that students take courses in security. And while I think some universities are taking steps in the right direction, this is typically an issue that companies have had to deal with after the fact. So, the chain is that students learn about computer science, they learn how to write software programs, they get hired by companies, they may not have taken a security course as part of their training, they write some code, that code gets deployed on the internet, it's now accessible to millions of people in addition to hundreds of thousands of attackers, and someone starts exploiting the vulnerabilities. And so there's various offerings that have showed up in the market that help companies train their software engineers to deal with these kinds of vulnerabilities. So I'll mention a couple of those. One of them that, in interest of full disclosure, that I helped co-found is the Security Certification Program at Stanford. It's available online anytime. You can take the entire certification program online, or you can come to campus for one intense week and take 3 required courses or 3 electives. In addition to lectures about how these attacks work, the program contains hands-on labs where you actually conduct the attacks and then write your defenses, all against test websites that have been built for these purposes. There's also a foundational certificate available as part of that, so if you have zero security background, it can help you build up to speed to the point where you can take the advanced courses. There's an URL here, you can check that out. The core courses in the certification program are how to use cryptography correctly, how to write secure code, and security protocols. Important so that you get a feeling for what protocols have been designed to date and what have been some of the problems. There's also electives in the management of computer security. Emerging threats and defenses is a course that can be repeated for credit every year and talks about every year the new threats and defenses that have come up. There's an elective on securing web applications. So there's lots of information there. There's some other security certification programs that are notable. One is offered by ISC Squared. They offer a certification called the CISSP. It's very good at preparing people for administration and government jobs in security. It's a credential that can be used if you want to do PCI compliance audits for a living. Basically, you pass a long multiple choice test. Another certification that you can get by passing a multiple choice test is the GIAC Secure Software Programmer, GSSP. It's offered by SANS. This is fairly new, and it focuses specifically on secure programming, whereas the CISSP is much more broad and covers 10 fairly diverse fields. So those are other certification programs. There's a variety of good books, one by yours truly, of course, Foundations of Security, What Every Programmer Needs to Know. There's also a couple of other great books. There's Ross Anderson's Security Engineering, which I actually recommend highly to everyone because it's free. Ross was able to work out a deal with his publisher where you can access the full contents of the book online. There's Viega and McGraw's Building Secure Software, which is often referred to as the classic text in this space. It doesn't focus as much on web application, but it does talk about buffer overflows and race conditions and all kinds of other attacks. And then, of course, if you're going to be writing security-sensitive code, I'd encourage you to check out the Secure Programming Cookbook. It has lots of code examples of how to do input validation correctly, of how to call the OpenSSL libraries. Using cryptography can be very fragile. If you provide just one incorrect initial value, the entire security of your scheme can go through the floor. So you can check out that book as well. There's a number of very interesting websites. The OWASP website is one of them. It stands for Open Web Application Security Project. One nice thing about the OWASP is they have a chapter in almost every major city. There's the Security Focus website, and there's code.google.com/edu. I'll tell you a little bit about each of these. The OWASP I mentioned, there's a chapter pretty much almost every major city. They produce this top 10 list of every year what are the top 10 vulnerabilities. I provided some examples of their top 10 list. You can see that their top 10 list has evolved from 2004 to 2007. It's become much more scientific, and they're getting better with the categorization, which is great to see. Security Focus is the home of the Bug Track mailing list, where vulnerability reports are mailed out. I'd encourage you to check that out. There's lots of different focus areas for you to check out there. Finally, last but not least, there's code.google.com/edu, where we've started offering free informations so that if you need to teach a security course or you want to get a group together to learn security, you can just download free materials off of this website. Let's see. So I just want to conclude. What should you take away from this talk? Every software engineer should also be a software security practitioner. Joel might have mentioned that I work at Google. We're looking for smart people to help us with application security and botnets. There's lots of interesting problems to solve. We'd love to give you the opportunity to help us solve some of them. All of the resources that I mentioned in this talk are available at learnsecurity.com. One other thing that's available there is there are slides corresponding to each chapter of my book, Foundations of Security, so that if you need to teach courses quickly, you can go ahead and get that. Let's see, if you have any questions or you'd like to learn more, feel free to drop me an email and or visit my website, and I'll conclude there. Hope you